Solve the following system of linear equations graphically. X plus 2y equal to 3 and 2x minus 3y plus 8 equal to 0. Our first equation is x plus 2y equal to 3. When y is 0, we get x as 3, and when y is 1, we get x as 1. When y is minus 1, we get x as 5. Plotting this on the graph, we get this line. Now for the other equation, when y is 0, x would be minus 4. When y is 2, x would be minus 1. And when y is 4, x would be 2. Plotting these also, we get this. Now the common solution is minus 1, 2. So x is minus 1 and y is 2. This is the point of the intersection of two lines. So our solution is x is minus 1 and y is 2. Places A and B are 180 km apart on a highway. One car starts from A and another from B at the same time. If the car travels in the same direction at different speeds, they meet in 9 hours. If they travel towards each other with the same speeds as before, they meet in an hour. What are the speeds of the two cars? Let car 1 start from A with speed x km per hour and car 2 start from B with speed y km per hour, where x is greater than y. Now case 1 is when cars are moving in the same direction. Distance covered by car 1 in 9 hours would be 9x. Therefore, 9 times x minus y would be 180 because they meet in 9 hours. So, time into speed. So, the relative speed would be x minus y would be distance, which is 180, which gives us x minus y as 20. Now, when cars are moving in opposite directions, case 2, distance covered by car 1 in 1 hour would be x. Therefore, and distance covered by car 2 in 1 hour would be y. Therefore, x plus y would be 180. They both travel 180 kilometers in total. From 1 and 2, we get x equal to 100 and y equal to 80. Thus, the speeds of the two cars are 100 km per hour and 80 km per hour respectively. Prove that the lengths of tangents drawn from an external point to a circle are equal. Using the above result, find the length BC of triangle ABC given that a circle is inscribed in triangle ABC touching the sides AB, BC and CA at R, P and Q respectively, and AB is 10 cm, AQ is 7 cm and CQ is 5 cm. First we have to prove that the lengths of tangents drawn from an external point to a circle are equal. Here is a circle with center O and external point P. Two tangents, PQ and PR, are drawn. We have to prove that PQ is equal to PR. So our construction would be to join radius OQ and OR and also join O to P. Now in triangle OQP and triangle ORP, OQ is equal to OR because both are the radius. OP is common and angle Q is equal to angle R because each is 90 degree. Radius is perpendicular to tangent. So triangle OQP is congruent to triangle ORP by RHS congruence rule. Thus, PQ is equal to PR by CPCT. Thus, we have proved that the lengths of tangents drawn from an external point to a circle are equal. Using the same, we can say that when AB is 10, AQ is 7 and CQ is 5 as given in the question, AR would be equal to AQ. So both would be 7 centimeter. BP would be equal to BR, which is AB minus AR, thus 3 centimeter. CP would be equal to CQ, each equal to 5 centimeter. Now BC would be BP plus PC, so it will be 8 centimeter. And that's it. This is what we needed to find the length of BC. A boy whose eye level is 1.35 meters from the ground spots a balloon moving with the wind in a horizontal line at some height from the ground. The angle of elevation of the balloon from the eyes of the boy at an instant is 60 degrees. After 12 seconds, the angle of elevation reduces to 30 degrees. If the speed of the wind is 3 meters per second, then find the height of the balloon from the ground. You can use root 3 as 1.73. Let A be the eye level and B, C are positions of the balloon. Distance covered by the balloon in 12 seconds with the speed of 3 meter per second would be 3 times 12, that is 36 meters. Thus, BC is equal to GF, which is equal to 36 meters. Now in triangle ABC, tan 60 would be root 3. So h by x is equal to root 3, which gives us h equal to x root 3. In triangle ACF, tan 30 would be 1 by root 3, which is equal to h upon x plus 36. So h is x plus 36 upon root 3. Solving 1 and 2 equation, we get h equal to 18 root 3, that is 31.14 meters. So height of the balloon from the ground would be 1.35 plus 31.14, so 32.49 meters. Find the mean and median of the given data. So these are the classes. These would be their respective class marks. This is the frequency. So sigma fi would be 120 and height would be 5. We get u as x minus a upon 5. Our a is 102.5. Now frequency times u would be this. Sigma fu would be minus 39. And cumulative frequencies would be these. Now mean is given by sigma fi xi upon sigma fi times h plus a. Substituting the given values, we get mean as 100.875. Now median class is 100 to 105 because 60 would lie, n by 2 is equal to 60 and 60 would lie in this particular class. Median is given by L, which is 100, plus n by 2, which is 60, minus C, which is 57, upon F, which is 18, times H, which is 5. We get median as 100.83. So the mean and median respectively are 100.875 and 100.83. The monthly expenditure on milk in 200 families of a housing society is given below. Find the value of X and also the mean expenditure. Now total number of families is 200, which means X would be 200 minus the sum of rest of the number of families. So X would be 28. So these are the class intervals and the respective frequencies, and these would be the class marks. Now the product of class mark and the frequency, that is sigma, that is FIXI, is this. Now mean is given by sigma FIXI upon sigma FI. So we need to find sigma FIXI, which is 5,32,500. So mean is sigma FIXI divided by sigma FI. So it will be 2662.5. So the value of X is 28 and the mean expenditure is 2662.50.